So my first problem was problem 51, and it asks, Hooke's law describes an ideal spring. Many real springs are better described by restoring force equaling negative k change in s minus q change in s cubed, where q is a constant. Consider a spring with k equaling 250 newtons per meter and q equaling 800 newtons per meter cubed. Part A asks how much work must you do to compress this spring 15 centimeters. Note by Newton's third law, the work you do on a spring is a negative of the work done by the spring. So for part A, you have the work equation, which you can get by taking the antiderivative or integrating the force equation. And from that, you can plug in your K and your Q that it gives you as 250 and 800. And then you just do the equation given by the work and as the antiderivative of the force, and you get that it was 2.914 joules work done by compressing the spring by 0.15 meters. And then part B asks by what percent has a cubic term increased the work over what would be needed to compress an ideal spring. So for this, you'll be taking the second term and dividing it by the first term. And when you take this term divided by this term, you get that it's 0.036 or 3.6% in which the cubic term has increased.